We're continuing our final review packet solutions here starting with question 32. We're going to graph some conic sections. So here in 32 we want to have a parabola that has its focus at 2, 0 and its directrix at x equals -2. Can you picture a parabola? It has to wrap around its focus and away from its directrix. So we know we can split this distance pretty easily. If the focus is at 2, 0, this parabola has to have its vertex halfway between at 0, 0. So this distance is p, the distance from the vertex to the focus, and this distance from the vertex to the directrix is the opposite of p. All right, so what else do we need to know then about the equation of our parabola? It says graph the equation of a parabola. So what about the width? We could have any width we want here then, or how fast it's growing, the value of a. We know that a is going to be positive since it opens to the right. But we don't really care whether it's a large positive or a small positive. So the equation, we can answer some of these other questions very quickly here. The axis of symmetry is how we fold this parabola in half. So that would be y equals 0. We were given the focus to be at 2, 0, and we were given the equation of the directrix. That should have been filled in here already. So what does the equation of the parabola look like? We know that when it is turned sideways, it is of this form, and we could have other values here for our vertex of the x and y coordinates of the vertex, but here we know our vertex is at 0, 0. So all we need to do is give a value of a, and because it opens to the right, we want it to be positive. So wouldn't you say that +1 is as nice a number as any, to just leave this as 1y squared? Oops, no, this isn't going to work because we need to get a 4p. We know that we need this to be a value of 4p. Sorry, I'm not thinking about this being a focus problem instead of a function problem. So I guess we do know what we want here. We want the distance p to be equal to 2, so I better think twice. We do know what number we want there. We want it to be 8. Okay? So that value is 4p. The distance from the focus to the vertex is p units. Okay, now I fixed that up. Sorry, guys. 33. Write the equation of a circle with center at the origin and a radius of 1. So center at the origin means we've got a pretty simple equation here. What name do we give this in the trig graphs? If it has a radius of 1, it is the unit circle. So center at the origin, radius of 1. Okay. So what happens in question 34? Well, the center is no longer at the origin. What would we have to pick for x to get this back to 0? We would have to choose 3. What would we have to choose for y to get this back to 0? We would have to choose -2. So our transformations slide us in the opposite direction. And the radius, this is r squared, so our radius is 5. And if we're asked to graph this, find the center, and then count off the radius in a couple different directions. There's 5 units in that direction. There's 5 units in that direction, so you don't have to worry about having your circle be perfect. Our radius is 5 and our center is at 3, -2. That would be enough to label on your graph. All right, question 35. Do you recognize what it is? Because there are different denominators here. This has a coefficient of 1/9 and this has a coefficient of 1/16. with a plus sign in the middle. So it is not a circle, it is an ellipse. One direction is stretched farther than the other. So our center, just like we did for a circle, we'd have to go in the opposite directions to make these equal to 0. We'd choose 1 for x and -2 for y. So our center, if we start our graph right away here, is at 1, -2. And then for our ellipse, think what we do here. These values are a squared and b squared. So under the x, we take the square root of 9. So we're going to travel 3 units in the x direction. So this would be at 4, -2. And 3 units in the x direction this way. So we would be at -2, -2. Those are called our major vertices. And I'm not sure if I wanted the word intercepts here. I think I probably wanted the word vertices. Intercepts implies where it crosses the x and the y axis, and I'm not so sure I'm interested in that. If the ellipse had its center at the origin, then the vertices would be the intercepts. So that might be the reason for that confusion. Okay, so let's list these. These are called our major vertices, because this is going to be the, oh, I'm sorry, they are not. I better finish graphing here. 9 is smaller than the other denominator. So under the y, we're going to travel 4 units, the square root of 16. So we're going to travel 4 units in this direction, and 4 units going down in this direction. So we actually have a major axis that is vertical for our ellipse. Sorry, that doesn't look very elliptical, but I'm not going to take time to change the whole thing. All right, so our major vertices then, this axis is the longer one, so our vertices on the major axis are at 1, 2, and 1, -6. And the others are on the minor axis, so our minor vertices are at -2, 2, and 4, -2. I should have a -2 there. All right. Foci. Remember where the foci are on an ellipse. They are c units away from the center point. So we've got to figure out what c is. Remember that this longer distance to the major vertex was a. So our formula is like Pythagorean theorem, a squared and b squared. Should we put a plus or a minus? Here we can tell that c has to be shorter than a. So we put a minus sign here so that c will be smaller than a. So a squared is our bigger value here, 16. B squared, 9. So c is going to be the square root of 7. So how are we going to list this coordinate? Well, we started at our center point. Let's remind you here, the center point where we started. And now I'm going to go up the square root of 7. So I'm going to start at -2, and I'm going to go up the square root of 7 units to 1 foci. And I'm going to start at -2 and go down the square root of 7 units. Could you put those together with just a plus-minus sign? You bet. That would be just fine. All right. Length of our major axis would be 2 times a. A was 4. So we go 4 units up and 4 units down. So the length of the major axis would be 2 times a. And b is equal to 3. So the length of our minor axis is that in both directions, double that. So our minor axis has a length of 6. All right. Let's do a hyperbola. We know it's a hyperbola because of the minus. So again, x is the positive one, not y. So we know it's going to have a horizontal transverse axis. So we're going to go from our center. What would we pick here for x? 1. What would we pick for y? 0. And from our center point, we're going to travel 3 units left and right. So 1, 2, 3, and 1, 2, 3. And those are going to be the vertices. So whatever is the positive denominator, doesn't matter whether it's larger or smaller, whichever is the positive denominator. So we started at our center, and here we ended up with a vertex at 4, 0, and at negative 2, 0. So again, I wrote intercepts, but I'm sure I meant to put vertices. Here they happen to be the x-intercepts. So you can see why I was thinking that, but that's not the better name. Vertices is the better name. Now we know our hyperbola is going to be open like this, but we don't know how to draw it until we do our fundamental rectangle. So remember that we're going to travel the square root of 16 units in the other direction. So we're going to go up 4 and down 4, and these points have no name, but through these values we draw this fundamental rectangle, and through the corners of that fundamental rectangle we get our asymptotes. So a lot of work with graphs that have asymptotes during this semester. So here's our hyperbola approaching its asymptotes. So we get hyperbolas when we do some rational functions. Here we get hyperbolas, though, that have horizontal or vertical transverse axes. So these are the vertices. This is the center. This is called the transverse axis. And here it is a horizontal transverse axis because the x squared was the positive term. And what do we have left? We have to find our foci. So remember where the foci are located: inside the curves, just like they are for a parabola. The focus is inside the parabola. So look at how this value of c is bigger than this value of a. So how do we find this? C squared is equal to a squared plus b squared. So we add our two denominators together. 9 plus 16 is 25. So C is going to be 5 units from the center. So our foci here, if we started at 1, 0, this would be at 6, 0. And if we go 6 units in the other direction, so we would be at negative 5, 0. If my arithmetic is right. I hope I'm reading my writing correctly. We started at the center of 1, 0, and we traveled 5 units. So in fact, that would not be correct. I guess if we started at 1 and we traveled 5 units, that would be at negative 4. All right, that looks a little bit better. And our transverse axis is the x-axis, which has an equation of y equals 0. All right, let's see if I can quickly remind you how to convert to general form. I'm going to group the x terms together, and I'm going to factor out the 4. And I'm going to group the y terms together, and I'm going to factor out the 4. And I'm going to move the 20 to the other side temporarily. And now I want to complete 2 perfect squares, so I take half of the middle coefficient and square it. So half of 2 is 1. So I want to add a 1 here. And notice that we didn't really add 1. We really added 4. So if I add to the other side, that'll be a 4. And if I take half of this coefficient, negative 2, and square it, but I didn't really add 4. I really added 16. So now we've got 2 PSTs, and on this side we've got 40, and now to get it into our standard form we're going to divide both sides by that 40 so that this side will equal 1. So when we take 4 over 40, that will leave a 10 down here, and here we've got 4 divided by 40, so that leaves a 10. So what do we come up with here? The equation of a circle, because we're going the same distance. So I didn't notice that we were coming up with this. I should have been thinking that these 4s are equal. The alternate way of writing this looks like an ellipse with the axes the same length, so that would be enough to convince you it was a circle. But I could have left, since it's a circle, we don't need those denominators. I could have just divided the equation by 4. So what do we know here? We know that the radius is the square root of 10. So either of these two forms would be perfectly fine. Our center Our center is at -1, +2, and our radius is the square root of 10, which is a little bit more than